Hello, this is a talk about what I think is going to happen to JavaScript over the 2020s. So specifically, start the 10 years starting from 2020 all the way to 2030, and maybe a little bit beyond. So a very ambitious talk, and obviously I am going to be wrong, but it's nice to speculate a little bit based on what we know today. And to cover that, basically what we're going to cover is where we have started from and where we're going, and then a little bit towards the end. So this talk is in 5 sections. The first age going from 1997 to 2007. The second age, 2009 to 2019. I kind of skipped 2008, but we'll cover that a little bit. And then the third age is split into part 3 and part 4, which is the two theses that I promote for what I think is going to happen in the third age, which is the rise of ES modules and the rise of polyglot tooling. And then finally, we'll speculate a little bit on how this ends. Like, nothing lasts forever, and JavaScript will have its end day, maybe. So we'll talk a little bit about the first age of JavaScript. This is something that probably, if you've been doing JavaScript a while, you know this story well. So I won't spend too much time on it, but it's worth thinking about how it began. I think obviously the best source of it is the guy who started it all, Brendan Eich, and I highly recommend his talk at .js called A Brief History of JavaScript. And it was based on a lie. Like, it's not actually anything to do with Java. Java was just a popular language at the time, but it was based on a lie in another way, which was that when Mozilla invited Brendan Eich to create JavaScript, they were actually promising him that he could put Scheme in the browser, which is a language that he really liked, and he never got to do it. It's just an interesting idea, but really the first age is about forming the language, trying to find its ground. So here's all the attempts. I started to count in 1987. Obviously, it actually started in 1995, but the formalization was in 1997. 1998 added some sort of ISO standardization. 99 added more features which are pretty useful at the time, but then the formalization effort really fell apart for the next 8 years, and that was a pretty dark period. From 1997, like, it had a pretty good start, and then going towards 2007, like, it wasn't clear that JavaScript was going to survive at all. Like, there were all these dialects of JavaScript. Flash was taking over the web, and it was a pretty dark time in JavaScript. So I think you could sort of describe there being two tracks going on in the development of JavaScript, right? During the first age. The first was sort of all the dialects like ActionScript, Microsoft JScript. I even looked around and there was like Qt script and WML script, web mobile script, something like that. I don't know. It was for like embedded mobile applications. Anyway, fortunately, those things died out. During the first stage of JavaScript, the other standard toolkits based on the existing language also started arising. So user-land extensibility of JavaScript arose. Fortunately, we had that ability. So jQuery obviously was the winner, but also you had MooTools and Dojo. And others, like I didn't include EXTJS and a bunch of other logos in here. But there are two tracks, and the standardization actually won. I think the really pivotal moment is the one that was kind of like the hinge moment between the first age and the second age, which I kind of think of as a dark period. There were a lot of other things going on in the world, the financial system falling apart. But surprisingly, we reached some harmony because the standards people were trying to was split into two factions. There was an ECMAScript 4 faction, and then there was an ECMAScript 3.1 faction. So evolutionary change versus revolutionary change. And the reason that we call ES5 harmony is because there's a compromise that was reached in Oslo. And the canonical source of this is John Resig's blog post about this in 2008. So I highly recommend checking that out, and also checking out this book that was recently published. It's kind of a book, kind of a paper published for the ACM and Programming Languages conference, called JavaScript: The First 20 Years, and it's by principal authors of JavaScript. And so, yeah, I mean, 2008 was kind of like really the pivotal moment when it enabled all the other features to come together, because once we had some kind of consensus on what JavaScript is and how we evolve this language, it got a lot more momentum. And that brings us to the second age, which is the age that we just finished. This is the typo. This is 2009 to 2019. But yeah, so what happened in 2009? It was kind of the year of miracles. CommonJS was proposed, and based on CommonJS, Node.js was announced in JSConf EU that used CommonJS module system. And because of Node.js, Isaac Schluter also realized that you needed a node package manager, and of course we also got ES5 Harmony. So that's the pretty remarkable year for that we owe to a lot of what we have today as, and we accept today as like the default way that things are done in JavaScript, all based out of this harmonization effort, the launch of Node.js, the launch of npm, the launch of the standardization and proposal of CommonJS. These are all just like fantastic ideas that have lasted us a good decade or more, and you can see this play out in its implication over the next 10 years. So we started to have runtimes. Like Chrome apparently was also in the 08-09 period. We started to bundle that into native platforms, and now a lot of apps in the desktop are just Electron apps, and arguably that's that's been a controversial move, yes, but it's made it a lot easier to write for JavaScript developers to write desktop apps for sure. And then we brought JavaScript to mobile, to mobile phones, and that was React Native. But then obviously there was other efforts like Cordova and other really pioneering efforts there. And then we started to see emerging dedicated runtimes like Hermes from out of Facebook, where it's just running JavaScript on Android, and it's so hyper optimized because we need that kind of performance, and it's just a really good opportunity to do that. Apart from runtimes, we also have build tools. So I didn't know this, but apparently Google Closure Compiler actually dates all the way back to 2009, as well as CoffeeScript, Grunt Webpack, and TypeScript also in the sort of the 2012 vintage. 2014 you got Gulp and Tracer, but quickly Tracer was replaced by Babel, and then we got like the newer bundlers as well, like Rollup, Parcel, and also we had Bazel, which is out and about that period. So runtimes, build tools, and frameworks. Like you can see how once the language base is standardized, you can start to build so much infrastructure on top of it. Obviously, this is what a lot of us are familiar with because we use frameworks to do our day-to-day tasks. Angular, Backbone, Meteor, React, and Vue, and Svelte. I don't have much to say about this apart from like you can see a little bit of progression in terms of like what we like to write apps in. We standardize on this idea of the component. A lot of frameworks like the single file concept. We threw away a lot of like the backend scaffolding ideas that Meteor had, which caused a lot of weight. And it's just a very interesting evolution over time. And I'm not sure that we're done. And so there's a lot of innovation still to go, but it's definitely a lot easier than it used to be. Okay, so that kind of brings us up to today. And I have this little visualization. It's really hard to visualize 20 years of web technology. So pardon me if I left out your favorite technology. I just did my best. Like this is, this already took me like 3 days to like pull together all this history. But yeah, there was the first age and the second age. And there was a lot of development, right? Like once we got the base of the language done, that enabled a lot of this other development to go forward. And I think the main thesis is that really there's a changing of the guard every 10 years in JavaScript. And maybe we don't have the start and end dates exactly right, but there's sort of eras of like, all right, this is the thing that all the innovations happening at now. And then once there's a clear winner, you build on top of that. And then once there's a clear winner, you build on top of that. And hopefully we're moving ourselves towards more accessible tooling, more developers building more sorts of apps. Yeah. And there's reasonable arguments against a lot of these, but I think that it's in general we have always moved in a direction of easier tooling, and that's enabled more and more developers, and that's a good thing. Okay, the other thing I'll point out, which I won't include in this third age thesis, is the shift left in JavaScript tooling. So this is a thesis that basically people have been increasing the developer experience and catching bugs earlier in the development cycle and therefore reducing cost by shifting their error catching all the way left, from runtime to build time, from build time to commit time, commit time to save time to read time inside of the IDE with a language server. So the two talks that I recommend checking out on this is Svelte and the Great Space Elevator, as well as Growing a Meta Language, where you can see this thesis applied to frameworks and dev tooling. Okay, so the third age is really about clearing away legacy assumptions, and there's two sections to this. The first is clearing away the assumption of common JS and the rise of ES modules, together with the death of IE11. And then the second part is clearing away the assumption that of just existing JavaScript tooling. A lot of tooling now is not written in JavaScript, and we'll explore that a little bit, as well as they will collapse a lot of layers into a single layer, and we'll explore why that is. It's a pretty simple idea. I think it's just pretty profound in how deeply it's going to change the way that we do JavaScript. Okay, so the first part is the first thesis is the rise of ES modules. So for a brief refresher, probably everybody knows what an ES module is. You've already used it, but maybe you haven't needed to exactly to know why this is a big deal. I certainly was one of those cases. Basically, it's the thing where you put import and export there. But most workflows would have the import and export keywords transpiled by Webpack. It's not something that used to be run natively in the browser or in Node. It has a lot of benefits, like it's statically analyzable, and if you require it multiple times, it only executes the module once. It's deferred by default. It's strict mode by default. Like all the good things that one of the really challenging ways of evolving JavaScript is that you try not to break the web. There are cases where we've just deprecated behavior, but we really try hard not to do that. So there is, sloppy mode, the opposite of strict mode, which is the way that JavaScript is by default. But we realized that we wanted a different mode for JavaScript, and we implemented use strict. Whenever you make an ES module, that's just automatically opted into the strict mode. It doesn't pollute the global scope, and that's really nice. And it's now supported in browsers. So where previously you needed to run your import and export statements through Webpack and whatever for it to build its dependency tree, now you don't have to. You're still recommended to, and we'll talk about that later. But it's just a really good evolution. There are also the way that this syntax is done, and there are also other benefits that can be realized, but they don't exist yet, so there's no point talking about them because they might not ever come. It's also much faster. So here I have a video. Stay with me. It's only a minute long, but I'm also going to play this at like 1.5 times speed. So what we're showing here is how fast Vite is versus create React app. And this is kind of side-by-side comparison. I'm doing install times and run times. The installation time is basically a function of the amount of dependencies that are sort of chucked in there by default. But the other thing that we really want to talk about is the runtime. So here I have the project running and it's live in the browser. And this is how quick it is. I put in some GIFs here to show how slow create React app is, because you're not bundling. Because Vite and other sort of new age ES module based developer tools don't need the time to bundle, or they don't have to bundle the entire graph. Like if they just serve you the files that you requested, and that's a much faster process, and it also scales much better as like a constant time, air quotes, version of scaling, rather than having to recompile the entire asset tree because that's the way that your assumptions work. Okay, so there are limitations to ES modules. It's not a cure for everything. So this is a recommendation from the official V8 write-up on ES modules, basically saying that your recommendation is to continue using bundlers before deploying modules to production, especially if you have a web app with more than 100 modules, which a lot of web apps are going to have that, especially for UI. Like if you're handwriting a lot of your modules, then sure, like don't even bundle it, don't bother. But there is overhead, right, for loading each module. And if you're going to load 1,000 modules and waterfall them across your wire, because we don't have export maps worked out yet, then that's actually going to be much slower than if you just bundled it. So we always want to optimize for user experience, and for best user experience, you should still bundle in production. But because we're doing local dev, we want a fast feedback loop. There's no reason to bundle during local dev because there's no network to cross. You're just on your laptop. So it's still an innovation that a lot of new age bundlers are taking advantage of, like Snowpack and Vite and WMR. So I highly recommend checking these out because these are clearly going to be the future of developer tools at least. Obviously, how much should we care about developer experience? We as developers care a lot. Our users should not even see it, but it should help us develop faster. So the other limitation, of course, is that it's supported everywhere except the one elephant in the room, the big E here, and that is Internet Explorer. It's mostly gone, especially in a lot of consumer sites. So Skillshare, LinkedIn, GoDaddy, Adobe, Dailymotion, LinkedIn, Microsoft in general, and Twitter, and other sites like YouTube have dropped it much earlier as well. But I think the key catalyst for IE11 really losing steam is going to be the U.S. government. So the U.S. government has a site where it monitors, like, here's the visits to all the web properties, and 2.6% of the visits are still Internet Explorer. But this is down a full percent since November 2020. So as of time of recording, 3 months ago, within the last 3 months, it's dropped 1%. It's going to be much harder to drop the remaining percents, but basically the U.S. government has a support rule of 2%. Like, once it drops below 2%, they can actually officially drop support across all U.S. government properties. And that's going to be a big signal to the rest of the market, especially anyone serving government sites, that, hey, like, the government's not doing this, like, you don't have to. So apart from all your peer companies doing this, banks and social sites and what have you, once the government goes in on it, then I think it's really going to be the death knell to IE11. The other thing which I really like is Microsoft proactively doing this in the Microsoft Edge browser, offering an IE compatibility mode. So even if you have applications that require IE, you can still use Edge most of the time, and then use IE mode just for those applications. And that's for enterprises that really need that. So I really like this strategy. You can see that adoption of ES modules is really happening. In 2020 alone, it tripled from 1% to about 3.5-ish%. And the key maintainers of the module ecosystem, so like Syndrasaurus, are just rewriting all of their modules for ES modules already. So by the end of April 2021, Node 10 will be end of life. So everyone will be using Node 12, and Node 12 can use ES modules. So it is happening, and this is the time right now to know about it, to start preparing to use the tools that are based with these assumptions rather than the assumptions of the second age of JavaScript. And this is the third age. This is happening right now. And IE11 will definitely be dead by the end of 2030. Okay, so the next thesis, the second thesis of the third age, is that we'll have new tooling. So Brandon Dale, formerly from Facebook, says that in less than 5 years, so he called this in 2018, so he's got another 3 years, most popular JavaScript tooling won't be written in JavaScript. And that's a fundamental insight here. So there's two insights here for me. The first is that we used to have this insistence that, like, okay, to reduce the barriers to entry, we have to have JS tools written in JS, right? So that they can understand and contribute. And then the other strong belief that we used to have was this Unix philosophy, like each tool should do one thing well. Both of these are going to go away. So first of all, the very obvious one is that TypeScript took over. Right, so most of the React ecosystem rewrote to use TypeScript. They're not just supporting TypeScript, they're using TypeScript internally. And TypeScript adoption in the general state of JavaScript survey is very, very high, like basically about 5%, 11% not using, and then the rest are interested or using it. So it's a very good result. I have had PRs and proposals rejected before on concerns of barrier to entry. And now it's just not even a question because it just improves the quality of the software so much. And that's the thing that actually matters. It turns out that most people don't contribute to open source. At least they're not going to contribute on the level of core maintainers. And yeah, we're past that tipping point. So once we have TypeScript core, what about other languages? So ESBuild is the other big bundler that is really sweeping the consensus. So all the new bundlers like Snowpack and Vite are using ESBuild under the hood instead of Webpack for production bundling, because it's up to 100 times faster than the existing bundling solutions. Why? Because it doesn't use JavaScript in the core. It uses Go. Like any compiled language is going to run faster. And I think the core insight is that this is something that we're going to see in every part of our tooling, because why should we wait for the slow initialization and all that? So these are other tools that are exploring Rust cores. So Deno is 53% Rust, Relay is 33% Rust, and Volta is 94% Rust. And these are all just like examples, right, of how JavaScript tooling is increasingly being written not in JavaScript. And I think this is a generally positive approach. Obviously, it's much harder to contribute because I don't know Rust, and now I'm unable to contribute to the core of these things. But there is still JavaScript in each of these things, right? Like, so I can contribute around the edges. And what this looks like, I think, is what I've been coming to call systems core scripting shell, which is that they're external APIs. This is the one that I care about the most in terms as a user, because I want to change it, I want to modify it, I want to write plugins to it. And it's only invoked very rarely, basically on initialization. And the core is the hot path, the code that will run recursively, continuously, 100 times more than the external shell code, right? So the core, if it's in the hot path, why are we still using JavaScript to do it? Why not switch to a systems language and communicate across boundaries? But once it's inside of here, it runs a lot faster, and that brings the overall speed of the tool to much faster as well. So I think we'll move from pure tools to polyglot tools, and I think that's a generally positive accomplishment, because there are just a lot more users than maintainers, and we just need our tools to be much better and faster. Okay, the second part, the death of the Unix philosophy. So this is a really good blog post from Benedict Evans. I recommend you read it, called Platforms, Bundling, and Kill Zones. This is more about regulation, but I want to make the point about bundling of functions together. In the 1980s, if you installed a word processor on your PC, they would not count with word counts, footnotes, or charts. You could not put a comment in a cell. You couldn't even print in landscape. These were all separate products from separate companies that you have to go out and buy for $50 to $100 each, right? And imagine if you think about the the way we do Microsoft Word today, it's all bundled. It's just one tool. It's like we take this as the standard functionality, right? Like we don't say like, okay, like this doesn't belong in the core. We'll have 5 different options for printing in landscape or counting the word count. And it's you see this pattern a lot in cars as well. When new technology emerges, it's very modular, and then we figure out what parts of the modules belong together, and then we just start shipping them as single individual units. And I think that's happening to JavaScript as well. Like, why are all these things different, right? Type checking, transpiling, formatting, linting, testing, and bundling. Like, a lot of them require individual AST passes, and because they don't know about each other, we're just running like ASTs like 5-6 times, and that's a lot of the argument of the authors of the new tools. Like, why are we doing that so many times when we can just do it once? And we don't have to. There's a lot of decision fatigue as well, and there's a lot of config files, right? Like who who's tired of like all the like Babel, ESLint, Webpack plugins here and there, and it's a very brittle system, and if any part of it breaks, like, good luck for trying to figure it out. Why not have one tool where everything's just guaranteed to work together? That sounds like a utopia. I think that's something that we have been trying to do for the past 5 years. So here's a complaint that was pretty funny about how hard it used to be to create a React app, because you have to wire all these tools together, right? Webpack and Babel and what have you. And of course, the React team came together and made create React app, but it basically just like took a standard package JSON and wrapped it up into one dependency. It didn't really solve the speed problem. It solved the initialization problem, because all you have to do is npm install create React app, but it didn't solve the speed problem and the tooling of like all the configs that you want to manage. So what the new distros are kind of doing is we're continuing this pattern on top of it. So create React app is like merging together React and dev tooling. And then if you add routing, then that's how you get Next.js and Gatsby. And if you get state data and components and hooks, then you get Blitz and Redwood.js. And there's just a lot of this like layer after layer after layer of React distributions. But what I'm really interested in is collapsing the really fundamental underlying layer into one single EST tool and one single EST pass and one tooling or one binary. So I think the leading candidates for this are Roam tools as well as Deno, which you can find out more later on as well. So those are just like really interesting ideas where like you collapse all the standard tooling into one. And I think it's time. I think we're all tired of like wiring these together separately, and I think we are in the process of shifting over to a new generation of tooling ready to combine all of these things into one. So that's what we're looking at really. And then the final part is speculation. I don't know what happens to JavaScript by 2030, but in the original impetus for this talk was this amazing talk, and it's really hilarious, called The Birth and Death of JavaScript by Gary Bernhardt, where he basically foretold what I'm exactly telling you, that JavaScript had a life from 1997 to 2035, and it went through quite a few stages, and he predicted the rise of something he called Metal, which is a language that was much closer to the Metal that eventually made JavaScript obsolete. And I think he basically called this the universal virtual machine. That's something that Brendan Eich also calls it. So the process of going through JavaScript helped us create this universal virtual machine that just runs everywhere, has the security features that we want, and just executes and not in an interpretive fashion, but like has all the qualities of the language that we like to work with. So Brendan has really started to modify his statement from always bet on JavaScript to always bet on JavaScript and WebAssembly. And I think the end of the third age will start to reckon a lot more with that. WebAssembly is not there yet, but it could very well conceivably be there by 2030. You can start to see examples of this with popular applications like Figma, where their UI is using a lot of this under the hood. Yeah, so that's a rough overview of like the thesis that we are in a third age of JavaScript. Hopefully it's been convincing. There's only two main arguments, one that we're adopting an ES module feature, and two, that we're collapsing all the layers. But you can see the long journey that we took to get there. And I hopefully have provoked your thoughts a little bit. If you're working on one of these tools, I really want to know about it, because I'm basically self-appointing myself as like a documentarian for the next 10 years. And if you're just a user of these tools, then I think you have a lot to look forward to. So I welcome your comments and questions. You can reach me at these contact details. And if you want to learn more about progressing yourself as a developer and spotting megatrends and strategic shifts for your technology choices, you can check out my book at learninpublic.org. Thanks very much, and enjoy the rest of your conference.